All right, let's say we have a battery and our two electrodes are going to be zinc over here and copper over here. And this is going to be just a voltaic cell because we're going to take a wire, connect it from the zinc to the copper. And if you look at table J, you would see that zinc is more active than copper. And so the spontaneous reaction that occurs is that zinc will start transferring its electrons over to the copper. And as it does this, this will start becoming aqueous zinc. And so since it's giving away its electrons, that is oxidation. So our anode reaction will be zinc goes to Zn2 plus 2 electrons. So that's giving away electrons, so that is oxidation. And oxidation always occurs at the anode. Now, since the copper is receiving electrons, we'll have some copper ions in here. And as those gain electrons, they start solidifying and start becoming attracted to that copper electrode in there. And so we'll have copper 2 plus in the aqueous form. And then we're giving them 2 electrons, and they will become just solid copper. So because the copper is gaining electrons, that is reduction, and reduction always occurs at the cathode. Now, what happens when this battery runs out? So we want to move those electrons essentially back to the side with the zinc so that this battery can be used again. So that would be like a rechargeable battery. All right, so let's look at this cell down here. All right, so we're still going to have our wire going from the zinc to the copper, but within this wire, we need to attach a battery. So this would be an external power. All right, and so the negative end would be over here, the positive end would be over here. And so the negative end of an external power source, like a battery, is going to start pushing electrons back towards the zinc. And the positive end of the battery will draw electrons in towards itself. So these electrons will start moving into the positive end of the battery. So now our electrons are moving in the reverse direction. So our zinc that was in the aqueous form in this beaker starts going back into the solid form. So we'll have zinc 2 plus in the aqueous form. They're gaining their electrons back, and so this is just becoming solid zinc. And so since that zinc is gaining electrons, now this would be reduction. And so during the process of the batteries recharging, the zinc then becomes the cathode. And so on the flip side, our copper will start becoming aqueous copper. So we have copper in the solid form is now going to copper in the aqueous form with a 2 plus charge, and it is losing its electrons. And so since it's losing electrons, that would be considered oxidation. And oxidation always occurs at the anode. So during that process of recharging the battery, the copper then becomes the anode and oxidation occurs there. And so this is considered to be not a voltaic cell, but now this process is similar to an electrolytic cell. So electrolytic cells do non-spontaneous reactions, because this is a reaction that wouldn't typically occur if they were just left to do the reaction naturally. Whereas in a voltaic cell, this would be a spontaneous reaction, because the zinc will just naturally want to give its electrons to copper because it's more active.